Welcome back to my channel, and today in this video we will talk about some of the important topics which is a part of descriptive statistics. Now this video is about some of the statistical concepts which are needed when you want to become a data science, when you want to become a data analyst or an AI engineer. These are the basics of the data analysis. So let's start with our main agenda. But before that, I want all of you to subscribe my channel, to hit on the bell icon and wait for my next video. And this will be a whole topic. This whole topics I will explain you with the help of a practical, because in a practical understanding you will come to know that how these things works. So let's start with the first thing. What are actually the descriptive statistics? When we talk about the field of statistics, we actually talk about the two things. One is the descriptive statistics, the, the second thing is the inferential statistics. So today our topic will be related to descriptive statistics. And descriptive statistics, it actually summarize and describe the feature of a data set. For example, I have a data set which contains the sales data. Here I have category 1, category 2 and price. So category 1 is actually the feature, and we will, when we summarize that feature, which means we are performing some descriptive statistics concept on that feature. Now do you understand what is this? It is actually nothing but to summarize any feature. So here the key concepts which will be used. The first is the measure of the central tendency. The second is the measure of dispersion. The third is the outlier detection. The fourth is the skewness. And the fifth one is the relationship, which is called correlation and covariance. So let's start with the first topic, with our very first topic, which is about measure of the central tendency. Measure of the central tendency, it actually find out the it actually some find out the midpoint or the average or the most repeated value or in a feature. For example, I have a feature which contains the sales volumes. So what will we do? Measure of the central techniques will do. It will find out what the average of these sale volumes. It can find out the midpoint of these sale values. And the measure of central tendency, it's all about this thing. So if someone talk you about what is measure of central tendency, you can say it is used to found the average when it comes to a numerical variable, when it comes to the continuous variables, it is used to found the average and the midpoint of the number. And when it comes to the categorical variables or string variables, it is used to find the most repeated value. So these are actually the three concepts in measure of central tendency. The first thing is the mean. In generally we use the arithmetic mean. Mean is actually used to find the average of a feature. For example, at the right side you can see we have a feature which contain the data 15, 3, 12, 0, 24 and 3. The mean is to calculate the midpoint of that number, not a midpoint, calculate the average of that number. So here I have applied np.mean, which is a predefined function in numpy, and it actually find out the average of a number. But there are some assumptions when you are using the mean. Make sure the data does not contain an outlier. What is outlier? Outlier is nothing but a value that disturbs the whole distribution. Let's talk about some practical example. Here I have a data set which is called 15, 34, 44 and 49. The one thing about this dataset is this dataset ranges about it ranges between 30, 1 to 50, but suddenly I got 1000. Now if I want to calculate the mean of this, I calculate the mean np.mean of this data. So what will be the mean is 228, but it should not be the average, because we have mostly number that are between 1 to 50, and it will disturbs all the things. So in this for this purpose we use the second concept which we will explain here, which is called the mode median. The median is actually used to find the midpoint value in a data set. Okay, we use the median when we have an outlier, and people try to prioritize the median when they don't know about the data set. They don't go for the mean just because maybe there will be some outliers, so we try to go for the median. So median is used to calculate the midpoint of any value. Now there will be a question in your mind: why we use the central tendency? Why we use the central tendency? Where we sometimes in a data set we have some null values. For example, I have a data set. I will here tell you. Uh, in that data set, I will create a data which is in the form of a dictionary. Here I have two columns. One is called the name, uh, the marks. One is called the marks. So the marks is nothing but we have a 10, we have a 20, we have a 30, and here we have np.nan, which is nothing but a null value. np.nan, we have a null value, and we have 40. I think I made a mistake here. Now that's good. Now let's let's create it into let's make it a data frame here. Now I have all these things. I have the null value here. Now I need to replace this null value. So for this purpose, if our data set does not contain any type of an outlier, so we can easily use the mean to replace this value. So first of all, I will assign it to the data frame, and then I will df dot fill na. df dot uh, in the df I will take the marks column dot fill na, and I will replace it with what? I will replace it with df marks dot mean. So I will replace it with the mean value. So if I click here, wait a second. So now it has been replaced. But what if we have a value like this, and we will copy. Wait a second. I will copy the whole data frame here, and I will again tell you. Okay. Now what we will have a value like this. Now this is a thousand value, which is actually called the outlier. Now in that scenario, we will use the median. How we can use the median? We can simply go with copy this whole thing. First of all, make it a data frame here, just like I did it today. I did it few minutes ago, and now replace it with the median because there is some outlier. And how to find outlier in a data set? I will tell you. Now if I applied the median, then it actually assign it with the 30. Now there will be a question in your mind how median works. First of all, it arranges the number. For example, if I have all these number on the right side, it will arrange it in a either descending order or ascending order. It depends upon you. So it will assign it on a ascending order. Now it will make a pairs from here. For let's explain you practically. I have a data set on which I have elements 10, 20, 30, 40, and I have a 50. Now it will make a pairs of data set. How? It will take these two values and it will take these two values. Now the pair, now at the end, I got 30, and the 30 will be my midpoint number. What if there is another number? What is if there is an even? Let's make it these two pairs. Let's make it these two pairs. It will cut these things, and it will try to reach to the end. It will actually make a pairs from the right side and also from the left side, and then it will reach to the midpoint. But at the midpoint, I have two values. Then it will what will do? It will the, add these values and divide it by two, so it will give us a median here. So in this way median works. Okay, it will make a pairs from right side and the left side, and it tries to reach to the midpoint. For example, let's again tell you another example in which we have more elements: 30, 40, 50, 60, 40. First of all, it made this pair, then this pair, then it made this pair, then at the end we need we actually conclude 50 and 60, and it will actually divide the 50 by 60, and it works like this. Okay, so it will first of all assign the numbers. Here I write 40 40, but it will first of all assign the number in ascending order. It will not be in descending order. It will descending order. It will be in ascending order. So this is actually called the midpoint. If I talk about the median, it is actually called the second tendency. Now there is a question: what we if we have some other variables which are called the categorical variables, then how to replace these values? Then for this purpose, we will use the mode, which will actually replace it with the most occurring value. Now here I have numerical values. I can also replace with the numerical to apply mode with the numerical variables, but generally we try to apply it with the categorical variables. Just because for the numerical variables we try to go for the median or mean, but for categorical variable we try to go for the mode, which is nothing but the most repeated value. Let's explain you with the help of an example, just because example gives you a good idea. So for example, I have a AKY, the name is. After that I have a KY, then I have a AKY, then I have a NP dot, then I have again uh, AKY, then I have KL. Now I have a we will assign it to a variable. We will assign it to a variable. If I click on np dot mode, then it will of a, and it will give me np dot mode of a. I think I made some sort of mistake here. np dot np dot np dot I think mode is not available in the, it must be available there. What if I called mode f? What will you do? I think mode is not available, so we will try to go with the. Wait a second. It must be. We will apply it. We will import it from the Skyfi. So I think mode is not available in NumPy. Import from Skyfi. Import stats. So we will use the stats dot mode and apply it here. What was that? Stats dot mode. It must be applied there. So why it gives me an error? And A is the argument. Wait a second. Argument, it is not supported with the numerical values. Which remove 1.1 to consider np dot unique. What does it mean? Let's try to go with another thing. We can also do some more thing with that. First of all, let's make a variable here. First of all, make a data frame here. Feed dot data frame. In that data frame, we will here we will make a dictionary. In that dictionary, we will make a names. So the names will be nothing but it will be all these things. I think there is an error in the library, so that's why it has not been giving me, and we will assign it to a here, to df. Now we have a df. Now we can calculate df dot mode. Now it will work. Now it has worked. It gives us the mode of aky. AKY is the mode. It's the most repeated value, so it has given us the mode as AKY. There was some error in the libraries, so I first of all I check the mode with the NumPy, then I check with the pandas, then I check with the Skyfi, and in the Skyfi there was an error. Then I went with the pandas, and pandas tell me what is the mode. So measure of central tendency, we actually replace it with the null values. So now these are the some of the important points you need to remember. When we talk about the numerical variables, try to go for the mean if there are no outliers. If outliers, then go for the median. If you're talking about the categorical variable, then you should try to go for the mode, which is the most repeated value and it's a generally used value thing. Now that was all the measure of central tendency. Let's talk about another topic, which is called measure of dispersion. Measure of dispersion actually tells you the variability of a data, how the data varies. So the first topic is actually the range. Range is simply nothing but it's the difference between the maximum value and the minimum value. So for example, if I have a data set here, And first of all, we will take the highest value from that data set, and we will subtract the lower value from that data set. And in the practical, you can see on the right side, so we have find np dot max data minus np dot mean data, and it has been applied. So the range between this data set is 23. The range is 23, which means the difference between the highest and the lowest value is 23. Now that was actually the first concept of measure of dispersion. Now the second is the variance. Variance means how the data varies. It's one of the important concept. It is the average squared difference. It is the Variance is the average squared difference from the mean. So it is actually the average squared difference. So what we will do, it will first of all, if I want to calculate the variance of any data, so it will what will do, it will take all the points, it will take all the points and it will take all the points and it will subtract it from the mean, and subtract the mean from that points. So what we will do, it will first of all take the 15 points, it will subtract the mean from it, and it will take a square. Then again it will take 3, and this process continues. So how it works, I will tell you in a practical way. So how the variance works. Now what the variance tells you, it tells you how the data varies in a distribution. So for example, I have a data set here which is 15, 20, 30, and 40. And let's suppose the mean of this data set is 30. Mean is equal to 30. So what we will do, wait a second. So what it will do, it will first of all take the 15 value and subtract 30 from it, and then it will take a square. Double quotation is used for the square. Then it will again use the plus value, then it will take the 20, then it will subtract the mean from it, and it will take a square again. It will up to the nth value, and then it divide it with the total number of the total numbers we have. The total number is 4. So in this way it will gives us the answer here. Okay, in this way our variance works, and it tells you about the variability of a data. So let's try to calculate the variance of this data. We have a data set in which we have element 50, 14, 25, 26, 27, and 28. Now if I calculate np dot where tells you the variance of this data, and the variance of this data is 26. It's the 26 value. Now if I check about the distribution of it, if I check about the variance of data in a, you can say in a plot, then you can also plot this data by using the uh, library called matplotlib.pyplot is plt. I will import this, and plt dot plot, we will apply the data here, and plt dot show. Okay, now the variance of a data is like this. It's the value which is called 26 value. So it means that our variance of data is not high. It's not high enough. If I talk about this data, and then the variance is 67.22. So it tells you about, it's the value of how this data spread, how this data spread. Now this data has also now let's if we talk about, wait a second, variance here, it will tell you now it's actually the variance here. If I talk about this is actually the variance. This is the variance concept. It tells you about how the data varies. These actually some of the variance values. Okay, now the second concept about after area. Third concept in measure of dispersion is the standard deviation. Standard deviation is nothing when you when you take the under root of a variance, then it is called standard deviation. Now what's the purpose of standard deviation? Standard deviation tells you that how the it's actually the rate in which the value is far away from the mean. For example, if I tell you, for example, it is the square root of the variance. It is the average amount of variability in a data set. It actually tells you about the average amount of variability in your data set. For example, I have a data set here which contains some elements. If i if i calculate, wait a second, I will tell you practically here so that you can understand. For example, I have a data set here. It contains the elements 50, 20, 30, 40, and 50. Now, if I calculate here np dot mean of a data, so it is actually called the mean. Now, if I calculate here another concept which is called np dot std, if I calculate about the data, so it means the 12. So, what does it mean? That this distribution is at this rate far away from the mean. This distribution is at this rate far away from the mean, and it is one of the important concepts when it comes to the data science, because we want to find how the data lies inside the mean. For example, if I tell you about, let's take this picture. Okay, in that picture we have this value of mean. I don't know what's the this value of the mean, and it is the first standard deviation. It is a second, and it has the third. So today we have calculated the first standard deviation. Okay, it's the first standard deviation. So for example, if you want to plot something, so at the midpoint there will be 32. Now at the after 32 there will be 32 plus 12, there will be I think 43. Then after that plus 12 there will be 55. So in that means it tells you how the data is far away from the mean. So standard deviation comes with the mean at the graph here. So here you can, it has been clearly seen that it has a first standard deviation, then it's a second, then it's a third, and it tells you on which standard deviation, and this graph tells you on which standard deviation our data lies. So this is the concept of a standard deviation. It tells you about how the data is far away from the mean. Now this is the fourth concept is actually called the quartiles. Okay, it divides the data into four parts: q1, q2, q3, and q4. Q1 contains 25% of data, q2 contains 50% of data, q3 contains 75% of data, and q4 contains 100% of data. How? Wait a second. Why will you use this concept? Let's go into the practical, because practical things gives you a great idea of how the quantiles work. For example, I have a data set here. In that data set, I have an element called 15. I have a called 45. I have 65. I have 75. I have 28. I have 29. Now I want to find out the 25% of data. I want to find out the 25% of data. In which range the 25% of data lies? And Q1 will tell you, quantile 1 will tell you on which range 21% of data lies. So if I click here, if I first of all convert it into array, first of all convert this thing into array, and again store in the data, because when we talk about the numpy works with the arrays. So we have created an our array. Now if I click on data dot quantile, data, I will apply on this data dot quantile. On which type of quantile we want? 0.25, which means 25%. uh, Wait a second, it must be here. Let's talk about the data. We have array. Wait a second, I think we made some sort of mistake here. Okay. Let's try to take the data we have. For example, we want to calculate, we will take the age. Let's try to take this column. which let's try to take this data dot age. Now I want to calculate what is the 25% of, what is the range of 25% of age. So if I click on quantile, now it will work here, 0.25, so 30. So what does it mean? That 25% of the distribution of age data lies under 30. If I click on df.age dot quantile 0.50, it tells you that 50% of data of age lies under 36 value. What does it mean? That that data is lies is, it is not more than 36. It may be 27, 22, 23, all this data, all this type of data, it will not be more than 26. If I click on here, 95, 75%, it is 43. So it means that 75% of data is find out, it's found under 43, and it also includes 43. So 25% of data is always less than and equal to 43. It's actually 75% of data. So these are actually the quantile, and I will not calculate the 100% quantile. 100% means, if I talk about the 100% quantile, then we will talk about the max. So let's calculate the 100% quantile. Okay, no, calculate the quantile one. It's not 0.1, it's 1. And also calculate the max. It will be near to max, or it may be max. These are max. The both are same. It will be max. So quantile 100 means 1. Quantile 75 means 0.75, and the quantile 100 and max, these both are same. So this is actually the concept of quantiles. Now we have till now we have calculated, we have talked about the measure of dispersion and measure of central tendency. Now let's move toward the next topic, which is called the outlier detection. Now we are moving towards the an important thing, how to detect an outliers. What are actually outliers? As I told you, outlier disturbs the normal distribution, and it actually change the conclusions. It actually change the summarization. So we need to remove these outliers. We need to replace it with some sort of value, or we need to remove it. Are the data point that deviates significantly from the rest of the data set? It actually changes. It is actually changes, and it actually deviate significantly from the rest of data set. They're not similar to a data set. They will always be not in a range of that data set. For example, in a data set I contain 1 to 10 elements. It will, this element may be 20, 30, 40. Outlier detection is the process of identifying the observations or data point that significantly deviate from the majority of a data. As I told you, these observation often lies as outliers because they lie outside the typical pattern, as I told you, or distribution of data. These outliers can skew, misleads, and result of data analysis and predictive modeling if not handled correctly. Okay, so in the basically we will use the two methods to identify the outliers here. We will use the two methods to identify the outliers. What is called the box plot. I will tell you what is actually the box plot. And the second is called the z-score method. Okay. So what we will do? Wait a second. I'm feeling a little bit tiredness just because I'm making video from a long time. So first of all, we will talk about what is box plot. Box plot is a type of a plot which is used to find out the outliers in the data, in our data. Okay. Now first of all I have a data set. First of all I need to make a load that data again here. Mm, we have a data as df.marks. Wait a second. Data is df. We have a data. So let's convert, first of all, convert this data into a data frame and then talk about box plot here. Data dot head. I have a data here. Now, if I calculate for this purpose, I will use the library which is called cbound as SNS. So if I talk about SNS dot box plot, and at x-axis, what I want the marks from the marks column from the data. So I use the SNS dot box plot, and here I want data. I At x-axis I want this. I want the marks column of a data frame. So if I if we click on here, then we will find out. I think there is no outliers in the data. So first of all, try to create an outliers. So the outliers will be 2000. Now this is the outliers. I actually loaded their data, so that's why I could not find the outliers. Now if I click on here, first of all, make it a data frame here. I make it data frame. Mm, Wait a second. I have okay made this data, and okay, now you can see there is some outlier. The value at 2000 is actually an outlier, and outlier looks like this point, and we need to remove these outliers. If you want to know why to remove, which way we can remove the outliers, I have already the video which I will give you in a description, which is the video, or I will give you in I section, comment section, which will tell you how to clean the data, and it comes in data cleaning. So here our topic is outlier detection. Now this is the first method. Here we can say it's a negative skewed. It's a negative skewed. It actually tells you about the bending of the data. If our data is bending at left side, just like here, then it's a called a negative skew. If it is at right side, it is a positive skew. The bending of data tells you that there are some outliers. It tells you there are some outliers here, and there are some outliers here. And if there are no skew, then the data will be looked as normal. So it describes the asymmetric dataset distribution, right? Positive skewness and negative skewness and zero skewness. So it is one of the concepts. Now there is a concept of covariance and correlation. So what does it tell? Covariance and correlation, these are tells you the relationship between two variables here. Two variables. So let's talk about the covariance and correlation here. This is one of the our today's final topic. So these both are the key concepts when it used to find the relationship between two data. So what does it tell? It tells you when you change one data, it will affect the other data or not. So the difference between the correlation is that covariance tell you the rate at which the data, at which one value changes when we changes the other value, and correlation will tell you the percentage of that data. So what does it mean now? So let's talk about the covariance. When one variable increase, the other values tend to increase, and vice versa. It tells it is a positive covariance, and it tells you how two variables change together. For example, I have a data set here. For example, I have a data set here. We will call the data here. I have two features, age and daily rate. Now I want to check how many, in which way they are correlated. So if I talk about the covariance, then it will tell you the exact amount, the exact amount in which the data changes. For example, we have a first column called we want to calculate the covariance between uh, this column. What we will do, we will use np dot I think there may be something. What's the notation of the covariance? Wait a second. I think I have right it there. I have right there in the slide. Wait a second. What is the correlation? What is the correlation? Yes, here. As you see, it will first of all take the first feature, np dot co. It is used to calculate the covariance. Now, what is the difference between covariance and correlation? I tell you, covariance will actually tells you the exact amount. It will tell you the exact amount in which the both features variate with each other. For example, if you increase one feature, then the other will increase. If you decrease one feature, the other will decrease. And the covariance between these two column, which is called sepal length and petal length, which is nothing but the here we take the parameters at 0 and 1. It actually ranges between it we can take this feature as by own. We can also take this feature as 0 to 25, 0 to 30. It depends upon us. So it will tell you 1.27 is actually the covariance between these two metrics. So what does it mean? When well value increases, there is a chance that 1.27 change in another value. Okay. Now, okay. Now there is a concept of correlation. Correlation which tells you the percentage in which these values are related to each other. I have calculated the sepal length correlation with the petal length, and it tells me that 87% there is a possibility that if we increase the sepal length, it will also increase the petal length. 87% it will increase the petal length. So this actually tell you the percentage in which these both things can changes, and it will tell you about the exact amount. Now what to tell? If it is positive number, then it means this is a positive correlation. If it is a negative number, then it means negative correlation. If it's a zero, which means there are no correlation. And the same is for the, if it is 1, then it means there is a positive correlation. If it is -1, then it means it's a negative correlation. If it's near to -1, if it's near to +1, it's a positive correlation. If it is 0, then it means there is no correlation between these two things. So these are the both concepts which I tell you about the descriptive statistics. Now let's move forward. Let's summarize. In the central tendency, we calculated the mean, median, mode, and in measure of dispersion, we calculate the variance, standard deviation, range, and visualize this. Outliers, we use the Z scores and box plot, and in the skewness, we check the distribution. And the one thing I forget about is actually about it's a Z score. So what we will do, Z score will first will actually calculate the score of these things, and if it is greater than if it is greater than if it is above than 3, it will be find the Z score will be ranges between 3 and -3. So if it is above 3, then that will be an outlier. If it is above -3, above, if it is greater than if it is less than -3, then it will also be an outlier. So here you can easily say that I have calculated with the help of I have applied the Z score in these things, and Z score what will do, it will actually identify outliers in our data set. So that was all from today's lecture. I want you to subscribe my channel, hit the bell icon, and wait for the next video. And I have a target of 100 likes on this video. If I got 100 likes, then I will explain the inferential statistics. So bye bye till now. Bye bye.